Hello everyone, my name is Teodoro. I am a principal engineer at Prometheux, and today I will be showing you how you can use Prometheux to turn your business knowledge into executable context for both humans and especially AI agents. So as it was being said before, we are kind of assisting to a change in enterprise AI. We are shifting from agents that are evaluated based on their ability to create into agents that are assessed, that are evaluated based on their ability to act. Point is, acting requires a different layer of understanding. Understanding what? Understanding the domain in which these acts occur, which means understanding the context, the rules, the ownership, the constraints, and so on and so forth. So one of the challenges that I think everybody here is interested in is exactly understanding how AI agents can best understand, access this context so that they can operate reliably in enterprise settings. We argue that this statement can actually be comprised of two main problems. A data problem, that is, we know that in enterprise especially, data is heavily fragmented, siloed, but not only that, also the context, the domain knowledge that would be needed for both humans and AI to understand such data is inconsistent, is ambiguous, and is siloed. For example, if I were to talk like, I don't know, about revenue, the concept of revenue, very well, both I as a person or an AI agent, if it needs to address revenue in the context of an organization in which like every department has a different meaning for that word, we would struggle, right? And the answer would not be great, especially if the goal is to kind of compute this revenue, is to actually perform a task over the data. So this kind of means that from a certain perspective, data cannot be interpreted correctly, especially in enterprise settings, if it's not paired with proper context. But this also means that your business logic, your context, is an asset, right? Is a proprietary asset, is almost an IP, and your competitive advantage that you should be able to kind of preserve, refine, and cure overall. The other problem is a model one. Now, we know that, and you were saying it before, that we've kind of been shifting from a bottleneck that was model intelligence towards a bottleneck that is decision context. The issue with models is that, of course, they are they, let's say, cannot provide, due to their probabilistic nature, cannot provide deterministic correctness guarantees, nor auditability, nor explainability that are essential in enterprise settings. Like, for example, if I were to, again, talking about revenue, if I were to try and compute revenue, like two different people could ask the agent to compute revenue in different instances. What would the agent do? Without the context, it wouldn't be able to, exactly for what we were saying before. But even with the context, if the task is left to the LLM, to just the agent, it would either fail or provide different answers, or even if the answers are the same, you would basically use twice the amount of tokens that you would need to use just to compute the answer, to define the answer once. So all of these kind of issues, both on the data side and on the model side, led us to believe that the way to address them is to provide agents with context that is not just readable, but that it is executable. More specifically, something that we like to call operational ontology. What does it mean? Basically, it means an ontology. So, as you all know, concepts, relationships that connect these concepts, that model your, basically your business, your domain. but also operational, because it is paired with executable logic that can be, once connected to data, processed deterministically, requested by a human, but also by an agent, so that the task of, for instance, computing the revenue is decoupled from the reasoning of the agent itself. It's like a tool that the agent can use. And basically, this is what Prometheux allows you to do. It provides you the infrastructure to build and manage operational ontologies. So you connect your data, you define your business concepts with executable logic just once, and then you connect it via MCP, via APIs to agents, so that they can orchestrate these tools and basically get context that is 100% deterministic, and at the same time that has been defined just one based on the ontology itself. Just a couple of slides to give you some context on Prometheux. At its foundation, Prometheux is an ontology-based processing engine. So basically it allows you in a single environment to define your ontologies, capturing everything that you could define in OWL, RDF, Shackle, as well as pattern matching languages like Cypher, SQL, PySpark, and so on. At the same time, it is both data agnostic, so it allows you to connect and process data wherever they are, or of whatever kind of source they are, from GraphDB to like unstructured data to relational data. And it's also compute agnostic in the sense that you can deploy it anywhere, and that it processes data in a parallel and distributed way, leveraging the computational resources at your disposal. Agents are able to connect to all of this via MCP. And this is interesting because it allows you to build something that is intrinsically a neurosymbolic infrastructure. What do I mean? I mean that agents do not only retrieve the context, they execute deterministically via the Prometheux engine the business logic directly against the live data that has been connected to the operational ontology. At the same time, agents do not act just as orchestrators, but they can iterate together with the human agent, the human user, that provides context over this operational ontology, enriching it, refining it, and so on and so forth. But let's move on to the actual demo. Let me see if I can, yes. Yes, okay. So what I will be showing you is a simple example of what I presented up until now. I'm using as agent, as you can see, Cloud Code, just because it's faster. And so as you can see in this first prompt, what I'm saying is that I'm a financial analyst. So like from a business perspective, I'm in finance side of things. I'm reviewing a portfolio of companies, and I have as context the Prometheux ontology called finance transactions. First of all, tell me which companies do we have and what's their KYC status. So while this is performed, we can see what this ontology is about. So here we are in the Prometheux platform, and you can see inside of this project a high-level view of the ontology. You have companies kind of interact with each other via transactions. They also have ownership relationships. So like a company can own a certain percentage of shares of another company, which builds basically a network of companies around ownership. And they also belong to a cluster. This is kind of the high-level view of the ontology. Let's have a look at the other view, so the operational ontology view. Okay. So basically, in this kind of this window, which we call lineage for obvious reasons, it seems like kind of an ETL process, and partially it is. I've been defining some concepts of the ontology, like transactions, like company, and something else that we'll see in a moment, and I've been connecting them to data. This data come from Postgres, MariaDB, this is an S3 bucket, about transactions, and the same thing about companies. If I were to go inside of the company definition, I would see this is basically a kind of one of the ways that in Prometheux you can define concepts. It's like a high-level declarative logic that you can inject here in these cells. As you can see, you can put also like Cypher or SQL inside of the body of these rules. And basically what we are doing here is just defining a company with a series of arguments or a series of features, and state that we will extract the data for these companies from all of these sources. So let's go back to the agent. Okay, wait, maybe there is one issue. Give me a second. Try to rerun it. Give me a moment. I just reconnected to the Wi-Fi here, so maybe that's just the problem. Okay. Should be fine. Here I'm showing you the current compute that I'm using is just a simple machine on our kind of from Azure, but as I was saying, you can leverage whatever kind of compute you want. Okay, perfect. Let's proceed. So right now is, okay, here it is. Right now is, what happened is that it called the concept company, which we were seeing before, without having any knowledge whatsoever on the agent side of the data that was connected to it, and the engine provided the agent with, in this case, a very simple, just kind of sequence of the companies involved in this small example. Very well, let's proceed further. Here we have been defining already some kind of additional concepts that are of interest for our use case. For example, one of the features that Prometheux enables is to perform graph analytics tasks without the need of a graph database. Like here, I defined a degree centrality concept, which is is defined in terms of a standard definition of degree centrality normalized. So basically, from the transactions and the companies, I can ask the agent to, for example, provide the most central nodes in the transaction network. So what will happen behind the scenes is that the agent will again call Prometheux. As you can see, here it is calling the degree centrality concept as a tool. It's very similar to just having a series of tools available via MCP, each of which corresponds to a certain executable logic that has been defined in the operational ontology. And here are the results. There are some interesting points that are observed via the agent on top of the data that has been inferred deterministically. And we can proceed like this for everything else. Like for example, another thing that I defined was clustering of these of the companies involved in this network based on their kind of connection via transactions. So basically connect the components based on transactions. So I can ask like, okay, now provide the summary of the clusters and their total volumes. Okay, it will do the same thing that we were seeing before for the degree centrality. In this case, it will again ask Prometheux to perform the cluster summary concept, the cluster summary task, starting from the data connected to transactions. Everything here is happening in memory. It's full on in memory. So this means that unless we want to materialize something, every time that we ask via the agent to perform a certain task, we will read the data from the different sources and like in a virtual layer infer the additional data via the new data via the engine up to the concept corresponding to the request. And that's what happened. So perfect. It identified 1, 2, 3, 4 clusters, one of which is just of one element, provided a summary, and plus some additional notes that the agent identified. Okay, so this is kind of a way, as you can see, to provide the agent with something that goes beyond just readable context. Because every time that we are doing this, we are performing potentially complex tasks, data processing tasks, just providing the agent with the ontological view. So the only thing that the agent is seeing here are the concepts that I've been showing you here in the lineage. And it is treating them as I was saying, as tools, as a way to basically split the task into the orchestration layer that's left to the agent and the actual processing layer that's left to the deterministic engine. One last thing that I wanted to show you is actually this. As I was saying, the relationship here and the synergy is kind of bidirectional in the sense that you can leverage the agent to improve, to expand, to refine the operational ontology that we've been using. For example, assuming that I am this financial analyst, I know that companies with a degree centrality score that is over 10% and that are owned with a share greater than 50% by another company, if this other company has a KYC status of pending, so they're something that probably a financial analyst would want to delve deeper into, they should be flagged as high priority so that they can be evaluated further later, for example. And now I can ask the agent to first of all, attach this note, this information to my ontology. So what happens is that it is the agent is saving this analyst note, as we are calling it, to the context associated to the ontology. And if we go here in the platform to the document view that kind of provides everything from the lineage to additional unstructured information attached to the ontology, we can see this information. Very well. What can we do with this? For example, we can say, okay, let's promote it to a new concept, like a new single concept in the ontology. And now the agent will do one other tool that Prometheux provides it, that is modifying the ontology by reformulating the unstructured content into the declarative format associated to the concepts. Very well, perfect. Yes. Yes. Let's create it. Okay. Let's give it a second. So now it's calling a dedicated tool to perform the translation into declarative logic. Very well. And if we now go back to the lineage, we can see that the new concept has been defined as we were requesting it. Now, actually, let me show you one more thing. I will compress this in the structured format. Let's actually run this as one last thing here from the platform. So basically, let me show you what has been happening behind the scenes every time that the agent called a Prometheux concept. Let me run it here. Okay. So what is happening here, as I was saying before, at runtime, in memory, the data is being fetched throughout this lineage, going through all the dependencies and concepts that have been involved in this task, up to the high priority review that provided 2 results.
1 minute.
Yeah, perfect. Thank you. That provided 2 results. So among all the companies that we had before, the ones that have been flagged according to the definition that we provided are Alpha Tech and Commercial. And you can imagine that this is kind of a small demo, right, with a small amount of data and a kind of limited number of concepts. You can imagine that scaling this up, which happens a lot with enterprise customers, you will have a very complex lineage with very different definitions, potentially of the same thing, exactly like we were seeing for the revenue before, with data that behind the scenes is completely siloed, like in this case actually, and providing the kind of the agent with the visibility of just these concepts proved in from our experience to drastically improve in these enterprise settings the way that agents behave. At the same time, just to connect to what you were saying before, we observed a huge decrease in and of course a cost saving in terms of tokens, because clearly the role of the agent in this case of orchestration and management of the ontology is much more contained rather than performing the full-on operations itself with just context that's being fetched and read. And this closes the presentation. Thank you very much for your attention.